morning students. Today I will be teaching you about the fourth normal form. Now before understanding the fourth normal form, you need to understand what multivalued dependency is. So let's start with it. A dependency A determining B as shown by two pointed arrows from A to B. So that's the dependency. So a dependency A determines B is said to have multivalued dependency if the first point is for a single value of A more than one value of B should exist, and the second point, for a table to have multivalued dependency there should be at least 3 columns. Then the third point is for a table with 3 columns A, B and C, the columns B and C should be independent of each other. Now, if it satisfies all these 3 points, the table will have multivalued dependency. Now consider the example in this slide. The attribute student ID determines the attribute subject. When this happens, the attribute student ID with value 1 corresponds to two different subjects, which are entrepreneurship and interior designing. Such cases give rise to multivalued dependency. Multivalued dependency is represented by two pointed arrows. Now see the difference in both the representations. In the first representation, where A determines B, the representation involves a single pointed arrow, so it's a functional dependency. In the second representation, where A is determining B, the representation involves two pointed arrows, so it's a multivalued dependency. Now let's come to the fourth normal form. A table is said to be in fourth normal form if it satisfies the following two conditions. The first condition is the table should be already in Boyce Codd normal form, and the second condition is there should be no multivalued dependency. Just consider the table student in this slide. It consists of 3 columns: student ID, course and hobby. Now, if you analyze the table student properly and see the columns, you will notice that the columns student ID and course are related with each other, as a particular student can enroll for a particular course. Again, the columns student ID and hobby are also related with each other, as a particular student may be interested in a particular hobby. But if you see the columns course and hobby, they are in no way connected with each other, as they are two different entities which cannot be related with each other. As a result, it has already satisfied the two conditions out of 3 to have multivalued dependency. Those are: the table has at least 3 columns which are student ID, course and hobby, and out of these 3 columns, 2 columns are not related with each other. Those are course and hobby. Again, if you look at the table student, you will notice that one student is opting for 2 different courses and also have 2 different hobbies. As a result, it also satisfied the third condition for a multivalued dependency. So clearly, this table gives rise to multivalued dependency. Now let's understand this example. The student with student ID 1 opts for the courses entrepreneurship and interior designing, and he is also interested in the hobbies chess and carom. That's why the first row in the table student shows 1 for student ID, entrepreneurship for course and chess for hobby. And the second row in the table student shows 1 for student ID, interior designing for course and carom for hobby. Now, even if the table seems to be free from anomalies, there still lies a problem. Since the same student is taking two different courses and is interested in two different hobbies, the two existing rows in the table also gives rise to two more additional rows, which are one entrepreneurship carom as the third row and one interior designing chess as the fourth row, which makes the table clearly redundant and it is a bad database design. Now, in order to eliminate this bad database design, what we can do is split or decompose the table student into two different tables, which I will show you in the next slide. Now, in order to eliminate the multivalued dependency, the table student has been decomposed or split into two different tables, which are course and hobby, as shown in this slide. The table course consists of two columns, those are student ID and course, and the table hobby also consists of two columns, student ID and hobby. These two tables, course and hobby, are already in Boyce code normal form. And also, since these tables consist of only two columns, so there is no question of multivalued dependency. As for a multivalued dependency, we need to have at least three columns. So multivalued dependency has been totally eliminated and the tables course and hobby are in fourth normal form.